Hello students, see this problem exercise 1.1 problem number 1 and part 5 we are solving this part. So here you can see the given set. Look, in the relation your given set is very important, and you can see in the question the given set let's say A, it is set of human beings in a town in a town at some particular time. This is your given set. And in the D part, how your relation R is defined. In the relation R, ordered pair x comma y such that x is wife of y. Ordered pair x comma y, if x is wife of y, and in the question number 1 we are checking only the three relation. We are checking for reflexive, we are checking for symmetric, we are checking for transitive. So firstly we will look for reflexive. You think for the reflexive what we look every element should be self related. Okay, so it means for the reflexivity we have to check x comma x, such pair should be in R. Obviously nobody can be wife of himself or herself, so obviously it is not reflexive. So you can write, since x comma x does not belongs to R, you can write reason also as nobody can be wife or herself. It implies R is not reflexive. Okay, R is not reflexive. So reflexivity we have checked. Now we will check symmetric. For the symmetric, suppose x comma y belongs to R. X comma y belongs to R. This ordered pair I have taken from R. What is the meaning? It implies that x is wife of y. Okay, x is wife of y. Now for the symmetric, yx also should be in R, but yx cannot be in R, because yx in R, if you say y comma x in R, it means y is wife of x. But if x is wife of y, then y is male. Surely y is male. A male cannot be wife. It implies by x does not belongs to R. It implies that R is not symmetric. Okay, it implies R is not symmetric. Now third, transitive. Is it transitive? So for the transitivity, we need connecting pairs. We need such pair x comma y and y comma z belongs to R. Okay, and there are three conditions for the transitivity. If there is no connecting pairs, okay, then by default it is transitive. And you can see here we will not having connectivity, because you see, if x comma y belongs to R, it means x is female and y is male. Then yz cannot be in R, because y is a male, and how male can be now wife? If yz belongs to R, then you have to say y is wife, but to be wife at least it should be a female first. So okay, so by default it is transitive. No connecting pairs, it is transitive. Okay, so by default it is transitive. How to write? You can write here ordered pairs x comma y comma z does not exist does not exist. So we need not look for x comma z in R. By default, okay, by default R is transitive. Okay, by default R is transitive. By default R is transitive. Okay, in the NCERT book they have given R is not transitive, which is wrong. Okay, which is wrong. R is transitive here. We are following just definition. R is transitive. Okay, now see question number 2. Question number 2. So now see question number 2. Question number 2. Show that the relation R on the set of real numbers is neither reflexive nor transitive nor symmetric. Okay, it is neither reflexive nor symmetric nor transitive. Okay, so as I say always, as I say always, you have to write your given set. What is given set here? Given set is set of all the real numbers. What is given set? R, set of all real numbers. Set of all real numbers. Okay, what is the relation given? Relation R, relation given ordered pair x comma ordered pair a comma b given, ordered pair a comma b such that a is less than or equals to b square. Okay, are you understanding what is the meaning? It means less than or equal to. Okay, any one condition satisfied, either a less than b square or a equals to b square, then also it will be in R. Okay, for example, if I say suppose this ordered pair 1 comma 1 will it will be in R. Suppose for example, if I say 1 comma 2, this ordered pair will be in R. Yes, because a value is 1 here and b value is 2, and obviously here a less than b square, because a is 1 and b square is 2 2 is 4, 1 less than 4. So here this condition hold, that's why 1 comma 2 belongs to R. Okay, if I say 1 comma 1 belongs to R, yes. Why? Because here a value 1, b value 1, both are 1, so it follows a equals to b square, because a is 1 and b square also 1, 1 equals to 1. So here this condition satisfy equal to. So are you getting? Either a less than b square or a equals to b square, any one condition satisfied, ordered pair will be in the R. Okay, now hope now it's clear that which ordered pairs will be in your R. Okay, now they said that prove that show that it is not reflexive, not symmetric and not transitive. So if it is not reflexive, we can give one example, counter example. Correct, R is not reflexive, R is not reflexive. R is not reflexive. Then we need to give one counter example. Counter example means example which will counter the statement of reflexivity. Okay, counter example. Okay, but how to think counter example? Your relations over the set of real numbers. Okay, and for the reflexivity you always check a comma a, ordered pair a comma a. Now if you look a comma a, we have to see that real number a which will not follow this a less than a square, a less than or equals to a square. Which real number will not follow this? This is real number and this is square of real number. In general, square of any number usually the given number, except those case if your real number less than 1, if your real number less than 1, and we are looking for such real number which is this type, a greater than a square, a greater than a square. So less than 1, let's say 0.5, a value 0.5, 0.5 comma 0.5 does not belongs to R. Why? What is the reason? What is the reason? Because 0.5 not satisfying 0.5 whole square. 0.5 whole square is 0.25. Okay, 0.25. So obviously this is not satisfying because 0.5 is greater than its whole square value coming 0.25, and which is greater than this value is greater than. Actually here this relation hold. That's why it is not reflexive. So obviously this is not a reflexive. So many examples are there. You can check 0.3, 0.3 also not in R, because 0.3 is greater than 0.3 whole square. 0.3 whole square is 0.09. Okay, 0.4 you can take. So many examples are there. Now R is not symmetric. R is not symmetric. R is not symmetric. R is not symmetric. So think of a counter example. Suppose if you are taking 1 comma 2, 1 comma 2 belongs to R, correct, as 1 is less than 2 square. Okay, as 1 is less than 2 square. So 1 2 belongs to R, but 2 comma 1 does not in R, as 2 is not less than or equals to 1 square. 1 square is 1 again, but 2 is not following this. So 2 1 not in R. So this is the counter example. R is not symmetric. Now R is not transitive. R is not transitive. Look for a counter example. This is also a counter example. Okay, so for the transitivity we look ordered pair AB and BC type. So we have to think 3 numbers A, B, C. Okay, suppose if I take A value 3, B value 2 and C value is 1.5. okay, then you can see A comma B belongs to R, B comma C belongs to R. Why? Because why this belongs to R? Because 3 is less than 2 square. Okay, 2 square is 4 and 3 is less than 2 square. So this one condition satisfied. So AB belongs to R. Why BC belongs to R? Because B value is 2 and 2 is less than 1.5 whole square. 1.5 whole square is 2.25. okay, so AB and BC in R, but A comma C does not belongs to R. A comma C does not belongs to R. Why? Because what is the reason? Because A value is 3. A value is 3 here and C value is 1.5. So 3 is not less than or equals to 1.5 whole square. 1.5 whole square is 2.25. Actually 3 is greater than 2.25. okay, so AB and BC belongs to R, but AC does not belongs to R. So it is not transitive. It implies R is not transitive. Okay, so we have shown that R is neither reflexive nor symmetric nor transitive. Okay, R is neither reflexive nor symmetric nor transitive. Okay.